Hello everybody and welcome back to the continuation of the Algebra series. Today I'm going to be going over real numbers. I'll tell you what they are and what different types there are. If you have any further questions or concerns, feel free to leave a comment down below. I'm going to have to work backwards in a way in order to explain what a real number is. First, we have to know what a natural number is. A natural number is what you think of when you count objects. Say someone asks you to count how many people are in a room. You start by going 1, 2, 3, and actually counting them out. This gives us the natural number line. The ellipsis, also known as the three dots at the end, just tells us that the list goes on and on forever, all the way to infinity. The next set of numbers is called whole numbers. This is just the natural numbers plus a zero added in. Moving on from there, we have integers. Integers include the whole number line and negative whole numbers. Notice that this line also goes on forever, but this time it's in the negative direction and the positive direction. After that, we introduce rational numbers and things get a bit more complicated. Rational numbers are basically one integer divided by another integer. One thing to note is that we can't have a zero for the denominator. This set of numbers also includes all of the sets we discussed before. You can write an integer as a rational number by putting the integer in the numerator and a 1 in the denominator. These can be either fractions or decimals. Rational decimals come in two forms, terminating and repeating. A terminating decimal is just a decimal that ends. In the example 0.25, the 5 would be the endpoint. Sometimes decimals don't end though. They can repeat the same number or set of numbers an infinite amount of times. A great example of this comes from dividing 1 by 3. To show you what I mean, I'll try using long division to find the answer. No matter how long we keep dividing, another 3 will be added to the end. To show this, we just write 0.3 with a line over the 3. This is what we call a repeating decimal, because it repeats forever. The simplest way I can define rational numbers is by telling you that they are real numbers that cannot be written as a fraction of two integers. So let's look at this in action. Here, we have a decimal that continues forever. Does it repeat? At first glance, you'll see that some of the digits pop up again, but it's not repeating the same set back to back. There are those pesky zeros breaking up our numbers. So we have to say this is an irrational number. Let's look at one more example. The square root of 2 is not a rational number because we can't write it as a fraction of two integers. An example of a rational number with a square root would be the square root of 4. 4 is just 2 multiplied by 2, so the square root of 4 simplifies to the number 2. Everything I've discussed so far falls under one big umbrella called real numbers. To help visualize this in review, we can do this. Start with the natural numbers. Then we add 0. Next, we include the negative numbers. After that, we add fractions and decimals. And then everything else. This is what real numbers are. If you're still watching, thank you for watching to the end, and give a thumbs up or comment if you found this useful. Next time, I'll be covering PEMDAS, also known as the order of operations. Stay tuned, and I'll see you next time.